You've probably imagined it, standing at a starting line, picturing what it would feel like to run faster than a car, faster than a jet, faster than light itself. No traffic, no waiting, just you, arriving everywhere instantly. It sounds like the ultimate human fantasy. But the real answer is far stranger than speed. It has almost nothing to do with running. It has everything to do with what you would stop being. Your body was built for a narrow range of speeds. Walking, sprinting, maybe 80 miles an hour in a car if you're brave. Light moves at about 186,000 miles per second. To even compare your body to that number, you have to leave behind everything your senses were built to understand. So what actually happens if you push a human body toward that speed? Not in a cartoon, in real physics. The first thing to understand is time itself. In 1905, a young patent clerk named Albert Einstein published a theory that would rewrite how humanity understood motion. He called it special relativity. Inside it was a strange claim. Time is not fixed. It bends depending on how fast you move. The faster you go, the slower time passes for you, relative to everyone standing still, not as an illusion, as a measurable fact. This isn't theoretical anymore. In 1941, physicists Bruno Rossi and David Hall studied tiny particles called muons, created when cosmic rays hit the upper atmosphere. Muons decay fast. They shouldn't survive the trip down to sea level, but they do, in huge numbers, because they're moving close to the speed of light. From our point of view, their internal clocks are running slow. Time dilation measured in a falling particle. If it happens to a muon, it would happen to you. So imagine you're running at 99% of light speed. To you, inside your own body, everything feels normal. Your heartbeat, your breathing, your thoughts, all completely ordinary. But to someone standing still and watching you, your movements would look like slow motion. Years could pass on Earth, while only minutes pass for you. Run fast enough, long enough, and you could outlive everyone you left behind. Not because you aged slower biologically, because time itself moved differently for you. Strange thought, isn't it? This isn't just a hypothetical about runners and muons either. Physicists describe a thought experiment called the twin paradox. One twin stays on Earth, the other boards a ship and travels near light speed to a distant star and back. When the traveling twin returns, they're younger than the sibling who stayed behind. Not by a trick of light or perception. Their body has genuinely aged less. Two people, born on the same day, now living in different rates of time because one of them moved fast enough to borrow minutes from the other's clock. Would you take that trade if it meant losing the people you love to years you never shared? You don't actually need light speed to see this effect in your own life. Every GPS satellite orbiting Earth right now moves fast enough and sits far enough from Earth's gravity that its onboard clock drifts out of sync with clocks on the ground. Engineers have to correct for it constantly, adjusting the satellite clocks by about 38 microseconds a day, or your phone's map would be wrong by miles within hours. Relativity isn't science fiction sitting in a textbook. It's quietly running underneath the directions you followed the last time you drove somewhere new. But time isn't the only thing that bends. Your body would also change shape. This is called length contraction, described mathematically by physicist Hendrik Lorentz just before Einstein's own work. As your speed approaches light speed, your body would appear compressed in the direction you're moving, at least from an outside observer's perspective, not stretched by force, reshaped by velocity itself. To someone watching from the sidelines, you wouldn't look like a person running anymore. You'd look like a flattened blur smeared across the horizon. And then there's the part your muscles could never actually deliver: mass. As you accelerate toward the speed of light, your effective mass increases, not because you're gaining weight, because pushing something that's already moving that fast takes exponentially more energy. Near light speed, your mass would approach infinity, and accelerating something with infinite mass would require infinite energy. This is the real wall. Not muscle fatigue, not a lack of will. Physics simply runs out of energy to give you. No human body, no rocket, no machine built from matter can ever fully reach light speed. Only massless things like photons get to move that fast. Ever wonder why light itself seems untouchable? This is why. Now suppose, just for the story, that some impossible force let you push past 99% anyway. What would you actually feel? Not speed. Speed isn't something your nerves can detect on their own. You only feel acceleration, the change. But you would feel something else, something violent. The world around you would start to look wrong. Objects ahead of you would appear compressed and blue-shifted, their light waves crushed together by your motion, shifting toward the high-energy end of the spectrum. Objects behind you would stretch and redden, their light waves pulled long and weak. Physicists call this the relativistic Doppler effect. At normal speeds, it's subtle, the reason a siren changes pitch as an ambulance passes. At near light speed, it becomes brutal. Here's the part almost nobody expects. Space isn't empty. It's filled with faint background radiation left over from the early universe, called the cosmic microwave background, first measured accurately by Arno Penzias and Robert Wilson in 1965. At rest, it's harmless, a faint whisper of heat left over from the beginning of everything. But if you were moving at extreme relativistic speed, that gentle background radiation would blue shift directly in your path. It wouldn't feel like starlight anymore. It would feel like standing in the beam of an X-ray machine turned up past lethal. You wouldn't just be fast, you'd be cooking, hit by radiation that used to be ambient, now weaponized by your own velocity. And that's before you consider the dust. Every stray hydrogen atom, every speck of interstellar debris would slam into your body with the force of a particle accelerator collision. At rest, a grain of dust is nothing. At near light speed, it behaves like a bullet made of pure energy. Your body wouldn't survive the friction of simply existing in space at that velocity, not because you're fragile, because nothing built from ordinary atoms was designed to occupy that kind of energy state. So the fantasy collapses the moment you look closely. Running at the speed of light was never really about legs or lungs or willpower. It was always a question about what a body made of matter is allowed to do inside a universe built on rules older than humanity itself. And the deeper you go, the less it feels like a superpower, and the more it feels like a boundary. A wall built into the fabric of causality, protecting the universe from something. Maybe protecting time itself from paradox. What is it really keeping you from? Here's the quiet twist most people miss. You are already moving through space-time at the speed of light, not through space, through time. Physicist Brian Greene has explained this idea in plain terms. Every object in the universe travels at a fixed combined rate through the four dimensions of space and time. Sit still, and all of that motion goes into moving forward through time, 1 ordinary second per second, speed up through space, and some of that motion gets redirected, borrowed from your rate of moving through time. That's why fast things age slower. They're not defying time. They're just spending less of their fixed budget on it. Think about what that means for the life you're already living. Right now, sitting still, reading, or listening to this, you are moving through time at full speed, the fastest rate available to anything in this universe. Every second you spend waiting in traffic, every minute you spend scrolling before bed, is a second and a minute spent at the maximum velocity the universe allows. You've never once stood still. Stillness, in the way you picture it, was never actually available to you. Which means the real answer to what happens if you could run at the speed of light isn't destruction or slow motion or a blue-shifted death by starlight, even though all of that is true. The deeper answer is quieter than that. It's the realization that you were never standing still to begin with. Your body has been racing through the universe since the moment you were born, just along a different axis than the one your legs were built to use. The satellites above your head are already living proof of it. The muons falling through the sky right now are already living proof of it. You just never had a reason to notice. So tonight, when you're walking somewhere ordinary, somewhere slow, remember this. You already know what it feels like to move at the speed of light. You've been doing it your whole life, just not in the direction you thought.